These are your uncertainty equations. Remember, it doesn't matter whether you're adding or subtracting, right? The uncertainty is always the sum of the uncertainties, and they'll try to catch you with that. Right? They'll subtract two numbers, and they'll try to get you to subtract the uncertainties. You always add the uncertainties, whether you add or subtract, right? This means anything that's multiplying or dividing. So, for example, if you run up a set of stairs, your power is your change in potential energy over time, right? This is just multiplying and dividing, right? So the uncertainty of power over power would be the uncertainty of mass over mass, plus the uncertainty of gravity over gravity, plus the uncertainty of height over height, and indeed even the uncertainty of time over time, right? So you can make, impressive equations with that. Really, when you get to be, you take grown-up physics and you understand what a partial derivative is. These are actually just partial derivatives, but this is kind of the algebraic equivalent of that. And then this is, remember that a to the n, right? A to the third is just a times a times a, right? And so if we were representing that product, we would say, so maybe the volume is the length of the side, right? Okay. Then the uncertainty of the volume over the volume would just be the uncertainty of A over A plus the uncertainty of A over A, because there's three A factors, right? And that's where it comes from, right? Because A times A times A is just A to the third, right? So we can represent this as 3 times the uncertainty of A over A, right? And then it's the absolute value because, of course, we can't have a negative uncertainty, right? Well, what would that mean, right? I don't even know. It's a negative uncertainty. All right, but yeah, they'll give you these questions probably in paper 1B would be my guess, and then they also have them on the multiple choice questions. All right.